What is a robot? There are a number of definitions, but a simple definition that serves our purpose here is a robot is a reprogrammable, multifunctional manipulator designed to move material, parts, tools, or specialized devices through variable reprogrammed motions for the performance of a variety of tasks. A robot also can be classified as a system that simulates human activities based on computer instructions. But now, what is an industrial robot? An industrial robot is defined as an automatically controlled, reprogrammable, multi-purpose manipulator programmable in 3 or more axes, which may be either fixed in place or mobile for the use in industrial automation applications. Some of the qualities that make industrial robots commercially and technologically important are the following. Robots can be substituted for humans in hazardous or uncomfortable work environments. Also, a robot performs its work cycle with a consistency and repeatability that cannot be attained by humans. Robots can be reprogrammed. When the production run of the current task is completed, a robot can be reprogrammed and equipped with the necessary tooling to perform an altogether different task. And finally, robots are controlled by computers and can therefore be connected to other computer systems to achieve computer integrated manufacturing. The common idea of an industrial robot is that the industrial robot is only an articulated mechanical arm, but this element is only one part of what is considered an industrial robot. So, the industrial robot has the following elements: the manipulator or arm, the controller, the driving elements, terminal elements, and sensors. The arm or manipulator of an industrial robot consists of a series of joints and links. Robot anatomy is concerned with the types and size of the joints and links and other aspects of the manipulator's physical construction. The robot anatomy affects its capabilities and the task for which is best suited. A robot joint or axis, as it is also called in robotics, is similar to a joint in the human body. It provides relative motion between two parts of the body. Robots are often classified according to the total number of axes they have. Most robots are mounted on a stationary base on the floor. Let this base and its connection to the first joint to be referred to as link number 0. For example, this link of here. It is the input link to joint number 1. This joint number 1. The first in the series of joints used in the construction of the robot. The output link of joint number 1 is the link number 1, and link number 1 is the input link to joint number 2, whose output link is the link number 2, and so on, as you can see in this figure. Nearly all industrial robots have mechanical joints that can be classified into one of 5 types. 2 types that provide translational motion and 3 types that provide rotary motion. The 5 joint types are: the first one, the linear joint, also called type capital L joint, And the real-time movement between the input and the output link is a translational telescopic motion with the axes of the two links being parallel. For example, here we have the first, the linear join. Then we have the orthogonal join, also called it type capital O join. This is also a translational sliding motion, but the input and output links are perpendicular to each other. So here we have the orthogonal join. Then the next type is the rotational join, or also called type capital R join. This type provides rotational relative motion with the axis of rotation perpendicular to the axis of the input and output links. So here, and we can observe that we can have the rotational relative motion here. Then we have the twisting join, or also called type capital T join, and this join also involves rotary motion, but the axis of rotation is parallel to the axis of the two links. And here we have the twisting join. And the last join called revolving join, or also type capital V join, and V from the V in revolving. In this join type, the axis of the input link is parallel to the axis of rotation of the join, and the axis of the output link is perpendicular to the axis of rotation. And this is the last one.